And we're back. It's good. Okay. So, where were we up to? We need to now do sign diagrams. I'm going to get rid of this for a minute so we can make a bit of space here and draw our sign diagrams in for the first derivative. So there we go. Now the interval that we're working in is between 0 and 2 pi. Okay. And this notation, x lies between 0 and 2 pi. Okay, so technically I don't need to go beyond that with my sign diagram, but as you know, trig functions are periodic, right? They repeat forever in a periodic manner. Although with our sign diagram we could be cutting it off at 0 and at 2 pi, okay? Like, yeah. Alright, I need to think about the space in here between 0 and 3 pi and 4, but I'm going to go all the way to 0 because 0 is something that's easy to work with trig functions, right? So on a unit circle, sine of 0 is just 0. Oh, here we are. I was at the right spot. First derivative, okay? I need to think about my gradients. Are they positive or negative? Are we increasing or decreasing? Okay, so I'm at this function here. Sine of x, sine of 0 is 0. Then we have cos of 0, that's 1, but there's a minus in front of it, so we are going to be negative here. All right. In between here, what's the easiest thing to work with? It would be pi. All right, maybe it is worth just doing quickly a little unit circle. All right, so the first value that I thought about was 0, angle of 0, or x equals 0, and I was here where cos is 1, sine. Now I'm going over to the angle pi and seeing what the gradient function or the first derivative is doing there. All right, cos will be minus 1, sine will be 0, okay? So sine value is 0, okay, but cos is now, if I put in pi into cos, angle of pi, x is pi, then I get minus 1, but it's times minus, so this is now positive, right? And I'm pretty sure that's going to be negative. Let's think about it though. If I maybe go up to 2 pi, right, so I've done a full revolution here on the circle. I'm going to test the x value of 2 pi, right? That means sine will equal 0, that means cos will equal 1, but then it's times by a minus, so it is negative. So we've got minima here. We've got just enough room to draw that in. Stationary point there, minimum. Here, gradient's going up, reaches 0, then it starts decreasing. We've got a maximum, and you would need to make a list, right? So you need to say, I've got a local min, right, where the x was 3 pi on 4, y value, not sure yet, come back to that. And I've got a local max at 7 pi on 4, and some y value, but we're going to need to work that out. How are we going to find those points on the actual curve? We have to go back to the function which describes the curve, the original function, right? Okay, so 3 pi on 4, it's in here on a unit circle. We've got a cos value there and a sine value of 1 on root 2. One of them's minus though. Which one? The cos. Minus root 2. 1 on root 2, sorry. Or root 2 on 2. I think I'll write it as 1 on root 2. And we're down here at 7 pi on 4 as well. That will be x is positive. 1 on root 2, and then we've got minus 1 on root 2 for our sine. Right, y values are negative. Okay, so if I plug in 3 pi and 4 into this function, I'm going to get cos equals minus 1 on root 2 minus another 1 on root 2. All right, I'll do this in another colour. I think red's a little bit aggressive. I'm going back to green, I think. So f of 3 pi on 4, you could just do this in your calculator if you like. Although if you're using a TI, it doesn't convert to surds automatically, so it might be better not to, right? So the cos of x at 3 pi on 4 is minus 1 on root 2. Now I think it's going to be a bit easier if we write the 1 on root 2. Can we just like recall that a 1 on root 2 is the same as, if I rationalize the denominator, a root 2 times the top times the bottom. What's root 2 times itself? It's equal to 2, right? By definition, right? Root 2 on 2. So what we've really got here is a minus root 2 on 2 minus the sine of 3 pi on 4, a root 2 on 2, which would equal minus 2 root 2's over 2, which equals minus square root 2, right? And that's approximately minus 1.41. Okay, so we'll just write it as minus root 2, I think. Okay. Now, my bet is that that one's going to be plus root 2. What do you think? So let's double check it though. Okay. What does the function spit out when I put in an x equal to 7 pi on 4? Okay. Cos of x, that's a 1 on root 2. But I'm going to write it, as a root 2 on 2, same thing. Then we're going to have minus plus a root 2 on 2. That will equal 2 root 2's on 2, which is just square root 2. Now to do a sketch, there's one more thing that would be nice, and that's a y-intercept. We're sketching between 0 and 2 pi, right? So drawing straight lines can be a bit tricky. Our sketch, let's say that's 2 pi there. Let's say this is 0, and we just need to sketch between here. But what that means is it'd be nice to put on a y-intercept, yeah, right? And then we'll just put on the min and the max, and that'll be enough for the sketch, right? Halfway between 2 pi is pi. This looks like about halfway. All right. This min will be at 3 pi on 4, so that'll be a quarter. How many squares? I've done 7, I think. 2, 4, 6, 7 squares. Oh, what's 3/4 of 7? Maybe it's about here. So the min's going to be 3 pi on 4. It's going to be down, if I make this square root 2, somewhere down here, right? But like I've been saying, let's find the y-intercept first. So the y-intercept always happens when the x value is 0. Okay, so it's always when you make your x equal to 0. And that will be at cos of 0, which is 1, minus sine of 0, which is 0. So you have 1 minus 0 is 1. Right, so we're starting at 1. Let me put 1 there. Okay, then we go down to a minimum. at 3 pi on 4. Now root 2 is higher than 1. Root 2 is maybe about there. Okay, so if I try to keep this somewhat to scale, minus root 2, about here, and that's where my minimum is going to be, about there, right? I'm going to try and have it fairly round. Okay. Now, the next, the point that I'm putting on is the maximum. It's over here at 7 pi on 2, that's about there on the scale. 7 pi on 4. I think I said 7 pi on 2. 7 pi on 4. Here we go. Alright, so that function's coming up. And it's going to max out here and come down. By the time it gets to 2 pi, it'll be back to 1. Right. Okay. Now, that's all the questions asked for. But we could, of course, look for things like points of inflection. Okay. So this function has a point of inflection here somewhere that you could find with the second derivative. And we could find what these zeros are as well from the original function. Spoiler alert, they'll be at pi on 4 and 5 pi on 4. But we've got a fairly comprehensive sketch just from the min and the max. All right, and remember these are just sketches. Okay, so like I'm saying, we could do more here, right? But I'll leave it there because I'm just going to answer the question as it was written. And it sounds like my neighbour is shooting a gun. Hopefully that's just to scare birds. Okay, peace out.